This is the second robotic lecture of CAM 810 S course. We go now into details and we start with the general characteristics of a robot arm. The working envelope is the space which can be reached by the flange of the outermost axis, which is called pitch, and on which the hand of the arm, the gripper, is installed. Look at the diagram to the right to understand this. The tool center point, TCP, is situated in the middle of the gripper fingers. The nominal load of the robot is the gross load, including the weight of the gripper, which the arm can carry and move. The point of action is situated on the flange of the pitch where the gripper is installed. Compare the diagram below with the diagram above, and you see how they are related. The maximum speed is the maximum constant speed, which can be reached with an arm with gross load. The accuracy of position is the accuracy of reaching a programmed point. It's the diagram in the middle. Repeatability is the accuracy in reaching a point several times from the same initial point. This is the initial point here, and these are 3 points which are reached one after the other, and this amount is the repeatability of the system. Degrees of freedom means the number of axes which defines the degrees of freedom. Actually, it refers to the freedom of movement of a rigid body in a three-dimensional space. In robot arms, the number of axes defines the degrees of freedom. There are two types of movement of a robot arm: linear or translatory movements, short T movements, and rotatory movements, short R movements. Form and size of the working envelope. This is the working envelope. Depends on the kinematics and the size of the robot arm. Translatory T and rotatory R, construction elements of a robot arm, are represented by graphic symbols. T axes are either telescopic, that means they move in this direction, out and in, or they are aligned. Moves means they are moving from the left to the right, from the right to the left. R-axis are of two types: not aligned and aligned. Moving axes are linear slide bases, for instance, LSB. Now this is the graphic symbol for a gripper. And two intersecting lines represent the system limit, whereas dash dot lines represent the limit of auxiliary axis. We shall see later on what this means. The different types of robots are also represented graphically. Cartesian or gantry robots, that's another name, are composed of three translatory t-axes. This is called a TTT design. The positive properties of such a type of robot are a good stability. It can carry heaviest loads. And the controllers are relatively simple. A negative property is its limited agility. Robot arms with simple cylindrical coordinates may have one rotary axis and two translatory axes, and are therefore called RTT design. Positive features of such a robot are a relatively simple controller and a sturdy design. Negative is the dangerous swivel out of the arm. The Polar Type 2, Type 1, excuse me, has two R-axis and one T-axis. It's therefore called RRT. High agility is positive, and negative is a relatively small working envelope. It's a bit limited. And a more complex, that means also more expensive controller. Remember the first robot, which was constructed in 1954? The Unimate is of this type. Now the Polar Type 2 has got three R axes. We call it therefore also that it is a RRR design. Positive is its high agility. It requires relatively small space, and it can be employed for many types of applications. Negative, from the cost point of view, is a more complex controller and a lesser accuracy. This type of controller is called, or of robot, is called a vertical articulated arm robot, a VAA robot. It's one of the most widely used robots. Cylindrical type 2 has got two R and one T axis. Positive are its high speed, its high accuracy, and its high repeatability. Negative are the dangerous swivel out and a limited field of applications. This type of robot is called SCARA robot. And these 5 letters SCARA mean Selective Compliance Assembly Robot Arm. That's why it is often used for assembling components. Let's now look at the 3 mostly used types of robot arms. The Cartesian or gantry robot has got 3 transitory axes, which provide a prismatic working envelope, a prismatic working envelope. Cartesian or gantry robots are typically used for loading and unloading of CNC lathe machines, for assembly, and for palletizing. Horizontal rotary arm or SCARA type robots are of a RRT design. They have a somehow sickle-shaped working envelope and are used for assembly, drilling, milling, and quality control tasks. The vertical articulated arm or VAA robot arm has got 3 R axes. Its working envelope is somehow spherical. And these robots are widely used for welding, deburring, spray painting, and handling. The robot in our laboratory is of this type. Combining the graphic elements, which we have seen now previously, a 5-axis VAA robot arm may be represented as seen to the right. Starting from the base, we have an aligned R axis and 2 non-aligned R axis. Those 3 are the so-called main axis of the robot. One non-aligned and one aligned axis are so-called auxiliary axes. The gripper is attached to the last axis, to the 5th one. Another special type of robot is the delta robot or parallel kinematic robot. Unlike other robot arms, its base is on top and its end effector or gripper is above a surface platform or a conveyor, for instance. It moves in X, Y, Z direction. and its working envelope is cylindrical. Delta robots may also have translatory actuators. That means these elements are moving in a linear form or translatory forms. Such a delta robot is usually equipped with pneumatic cylinders. Characteristics of delta robots are rather special. The key concept is parallelograms, which restrict the movement of the end platform on which the gripper or effector is fixed. To pure translation, that means it moves only in XYZ direction. Additional to these 3 degrees of freedom, a fourth one, a rotary one, is added to the row of the gripper or end effector. All heavy components, such as motors, levers, etc., are situated on the base, which is on top. And links, joints, and platform are made of extremely light material, such as carbon fiber, reinforced polymer, CFRP. Since this platform, because of these reasons, has a small inertia, it can move at extremely high speed and extremely high acceleration, up to 12 g. Delta robots are employed to pick and place small objects from a few grams to maximum 1 kilogram at an ultra high speed and often in combination with vision systems. They are used to sort and pack small objects, such as chocolates, tablets, small components, and many others. This is the end of the second robotic lecture. Please watch the Unimate video and do the exercises.